Don't start doing
All right. What we're going to do today, guys, is we're going to put all of the legal moves that we've done so far into the inequalities. Now, before we start, I want to go back to what we discussed yesterday, was when is it that we have to flip the inequality symbol around? When do you have to do that? Bien.
when you multiply or divide by a negative.
All right, so when you multiply or divide by a negative number, remember we talked about how that negative number, inside that negative number, we have that negative 1 in there, okay? And when we multiply by negative 1, things change to their opposite, and that's including the inequality symbol. So what's the opposite of less than? Greater than. And the opposite of greater than or equal to is?
Less than.
All right, so like we know that. So when we do, that's one thing that we have to make sure of, is that you remember that. It's going to happen again. Remember I talked about yesterday how you can tell before you even start a problem if you're going to flip it or not. And that's where, if you can get good at that, and you know where you're headed, these will not trip you up. Okay? So, we're going to go back to, we're going to start with two-step. We've already done one step. We're going to move to two-step. We're going to move into multi-step. I'm actually going to have you guys solve some inequalities that you never even solved, these types of equations as well, just to keep it, just see if you can do them, just expose you to them, so you can, at least if you see them somewhere, you can still solve them. So the first thing, what would you do in this, looking at this inequality, what would you do first? Nick?
You subtract 14 each.
All right. Now remember, Mrs. Alms, I start off with, you could box the variable term. You know, that's something you don't have to do, but that's something that you still can do if you wish. So we're going to get rid of this term first, because in order to get x by itself, we have to get the term with x in it by itself first. So we're going to subtract or put negative 14. Now, does that flip the sign?
No.
No.
No, because we talked about multiply and divide by a negative. If we just put a negative number on each side, that's really subtracting. Isn't it the subtraction operation? So that doesn't count. So this less than or equal to sign is going to stay the same. All right? Now, you know, yesterday, remember how we looked at the variable term and you could decide if you're going to flip or not? Look at what I boxed. Look at the number that's with x. Right now, raise your hand if you know if we're going to flip or not. Because right now I can tell. Just by, you see why, this is why I boxed my variable terms. All right? So, Garrett, do you think you're going to flip?
No, we are not.
All right, so do you guys agree with Garrett?
Yep.
Because ultimately, aren't we going to, when we bring our 6x down, you can see the operation or what we're going to do next. And you know that it's going to stay positive, so that's good. What's 32 minus 14? What do we got? Harrison, what'd you get? 18, yeah. All right. Now, our last step, what are we going to do, Sydney?
Divide by 6.
We're going to divide by 6. And again, we are dividing, but we're dividing by a positive 6. And you see now, if you box your variable term, you're going to be able to know from the get-go if you're going to flip or not. So when you put that box around that variable term, if you have a negative number inside that box, guess what? You're flipping. Okay? That's just something that I used to use when I was a kid, just to remind you I don't forget. It's not the fact you don't know the process to get to the answer. It's the fact that if you don't flip, your check won't work. All right? So we got 1x is less than... Our answer is what, Tommy? 3. Now our checks are going to be a little bit different today. Obviously, we're going to go back to the top. Remember, we're going to use what is typed for you, what is given to you. Remember, you don't use any of what you've written. Remember, when we start distributing, we don't use after we distribute. You go back to the original problem. So we have 6, and we're going to put x in there, which is a 3. Oh! We got to graph it first, don't we?
Yep.
Yeah.
Sorry. My fault. We can't put 3 in there. Oh, we could, but
Yeah,
we could, but in this case, we're going to wait because we have to make sure we can choose. I'm going to have you guys choose which one you want to do. So we got 2, we have 4, and is it an open or closed dot?
Closed.
Closed. And does 2 or 4 make that inequality true? Alec?
2.
2, and so 2 is to the left, so we're going to move and make sure that our arrow goes to the left as well. Now, could we use 3 when we check?
Yeah.
We could, but in this case, because it's inequalities, we could choose 2. Anything less than 3? Anybody have a better number than 3? Because really, I don't want to use 3 if I don't have to, do I? Anybody remember? No one remember what I would have chose? 0, yeah. Because 0 is nice. I can multiply by 0 any day of the week, in my head. So let's put 0 in there just for fun. And we got 14, and then I can't go off my screen here. 32. All right, so now we got 0. Can't we do this multiplication in our head? So what's left on this side? 14 is less than 32. So do you guys see how I kind of skipped that step? I don't have to put 0 plus 14 there. You can do that multiplication in your head. Is that cool? Especially because it's 0. If it's something else, you might need to write that down. If it was like maybe negative 55 or something, if it was a bigger number than 0, you might want to consider doing that work off to the side, making sure your check is good. All right, but in this case, 0, that's why I like plugging in 0, because you can do that in your head with less mistakes. Okay, so is this good? We check. Is this true?
Yes.
We're good. Okay, yeah, Harrison, you got a question?
Yeah, on the open dot, can we use the number that is graphed?
No, so the open dot, like if there was a 3 on here, remember 3 you couldn't use. You'd have to use 2, or you'd have to use 0, or something less than 3, something left of there. But because this is supposed to be more closed in, sorry about that. But that closed in dot means that 3's, remember, closed means included in the solution set. Open means nope. Anything left or right of wherever the arrow is going. All right? So, let's go to the next one here. See if my screen, there we go. Now watch. Box your variable term just for fun. Let's just box it just for fun. Right now, before we even start, are we going to flip?
Yes.
Yeah. Do you see how, back you're like, oh, why am I boxing my, you guys gave me a hard time. I'm like, I'm not boxing my, do you see how clear that is right now?
Yeah.
See how that's going to help you? Remember I tell you, things I have you, at least I suggest, you don't have to box anything. But I'm just saying, it's very clear, because you can just focus right directly inside that box, that number with the variable, and decide right now, instead of our answer being the way that inequality is, by the end of the whole process, it's gonna be flipped. But we don't flip until that rule is applied. Okay? You do not flip the inequality until you actually get to the multiplication or the division step. Do you understand?
Mm-hmm.
All right? So, what term are we going to get rid of first? What term? Lauren?
18.
How do you get rid of a positive 18?
You subtract.
All right, so we're going to subtract 18 or put a negative with it to make that 0 pair happen. So when we get this term goes bye-bye, we have what term left over on the left-hand side? What's left? Lindsay?
Negative 3w.
Yep, negative 3w. This inequality is still less than. Do you notice it has not flipped yet? Remember, we did not multiply or divide yet, have we? You don't flip until that happens. Be careful. I had some students flip here and then flip it back. Guess what? Did it end up back to less than? Don't do that. Flip until you only can flip until you get to the division or multiplication step. So when you put 15 and negative 18 together, what do you get, Cabernet?
Negative 3.
Negative 3. Nice. All right, now we have what step left? What are we going to do next? Lauren?
You have to divide by negative 3.
Yep, you're going to divide by negative 3. And in this case, obviously, we have 1w. But because we divided, I'm going to circle remember I told you that I used to circle my inequalities when I knew that I was going to have to flip there. So I'm going to flip this around. And now instead of less than, it's now becomes greater than. Okay, because we also want the opposite of that inequality symbol. And a negative 3 divided by a negative 3 ends up being 1. Awesome. All right, let's graph this. Now, Harrison, I'm going to ask you a question here in a minute based on what you just asked me on the last problem, okay? Be ready. So we got 0, 2. Open or closed dot?
Open.
Open dot. What direction are we headed, Anna?
Left. Wait, no, right.
Right.
I have a question.
Yes, what is your question?
Can you flip the sign, the one step before, like where you circled it? Can you just flip the sign right there?
No. No, flip it from here, flip it when you get to this point. Okay, when you divide or multiply, that's when you flip it. Do not flip it any sooner. Because what happens, Anna, is some kids will flip it here and then they'll flip it again. Now you're back to where you began. Well, I flipped it. Yeah, well, you flipped it back to where it was. Okay? Remember, look at the beginning of our problem. We started off with what sign? What inequality symbol did we have at the beginning? Less than. What's the opposite of less than? Did we end with greater than?
Yeah.
That's a good check to make sure that that's where, you flipped it correctly. Okay? From beginning, your original setup, to the end solution, the end inequality. All right? So, what number can we use, Harrison?
2.
Can we use 1, Harrison?
No.
Okay. You see the difference? When it's open, you cannot use this. All right? You can use this, 2, but you cannot use the one that has a circle on it. All right, so I'm going to change my color here. So we got 18. You said you want to use 2?
Yeah.
Okay, so Harrison wants to use 2, guys. If you don't want to use 2, you don't have to. You can use something else. Varieties of spice of life. Not everybody has to do the same thing here, which is nice. So we have, remember, you have to go back to this setup where it's less than. All right, so there you go. So now we got 18 minus what? 18 minus 6. Now, a lot of you could probably say, Mrs. Holmes, I can do 18 minus 6 in my head. Good. Okay, that's great. Then you can skip from here to here then. What's 18 minus 6? 12. And is 12 less than 15?
Yeah.
So if you skip from here to here, I'm okay with that. All right? But if you...
Just make it negative.
I didn't mean to make it negative. Ha! There it goes. Disappeared. So, any questions so far?
Nope.
Do we have to skip that other one?
Mm-mm. I prefer not, because when you get to bigger numbers or a lot of negatives playing around and you got things going on, a lot of times if you break it down step by step, that's where less mistakes will happen. When you start to skip things and start to do things a lot more in your head, a lot of us start to make those silly mistakes. So, I say okay, but as soon as you start making mistakes, if people decide to skip that step, I'm going to make you write it all down. I just say write it all down, just to be safe. All right, here we go. Let's do this one. Anybody have an idea if we're going to flip or not?
Oh, yeah.
Just looking at the problem?
Yeah.
Or if I box the variable term here, I box that. Are we gonna flip Reed?
Yeah.
Yeah. Do you see how that number inside, right, attached to that C? As long as it's negative, we already discussed that yesterday. If we have a negative number attached to the variable, we're going to have to either multiply or divide by that negative number, which applies the rule of the flip. All right, so what's our first step? What's the first step, Sydney?
Add 15.
All right, so we're going to add 15 here. Add, and there we go. It all shows up at once. All right, so now, does that flip the sign?
No.
No, not yet. So we're going to bring our sign exactly what it looks like, because that's addition. You only flip when you multiply or divide. So right here we have, we got 0, don't we?
Yep.
So what's our next step? What are we going to do next? Greta?
Multiply by -4.
Multiply by -4, which cancels those two out, and we're going to also have to multiply by -4 over here. But obviously, we know that at this point, because we multiplied by this -4, what happens to our inequality symbol? We have to flip it. So now we have a greater than symbol, but really, isn't C really greater than up here? Up here on this part? Okay, so when we bring C down, look at the little point is now facing the C. So C, can you rewrite that if you'd like? Could you rewrite it with C is less than, right? Because isn't the little point facing here? 0, if you'd like. For the, yeah, Sydney?
But then won't that be going to get to?
No, because C is on this side. Because C over here, look, C is, when it starts, and up here at the top, C is greater than or equal to -15. It's still, C is less than. You see, because the little point is facing here. All right, so it's still flipped. We still flip. But remember how some of you like that C on the left-hand side? You don't have to do it that way. All right, you can just leave it this way. It's fine with me. All right, so we got our graph here. We got 0, -1, 1. Open or close dot?
Close.
Close dot. Nice. See what number I'm plugging in. All right, and then which way are we going? Left or right?
Left.
To the left. You singing Beyonce again here or something? Huh? All right, so we have our graphs. Now we got to go up and plug it in. So we got -15. Where am I at? There we go. Is less than or equal to 0 over -4, because C is 0. I'm going to plug 0 in. Anytime I can, that's the easiest part. All right. So now we have, is -15 less than or equal to, this is 0. What's a 0 and a -15 going to make? -15. So is this true?
Yes.
Yes, it is. So we're good. Any questions? How do you guys feel?
Good.
What if you had this situation? Anybody remember some things that we've had this happen before, where the negative was on the end? Do you guys, some of you, do you remember me suggesting something before you actually move on? Garrett, do you remember? What do you remember?
You can change it to -1/3 times n.
You could do that. You could change this right here into -1/3 n. Anybody else have another suggestion that you could do, Lindsay?
You just move the negative down to 3.
All right, so you could move this and you just make this a positive n and just move the negative there. Does it matter which way you do it? No. Because ultimately, if you change, when you multiply by this 1/3, isn't the reciprocal of -1/3 -3 over 1? And aren't you going to really multiply by -3 anyway? So it's going to end up being the same move. All right? So why don't you guys go ahead and do this one by yourself and see how it works out. A loner one. All by yourself. So I'm going to add 5 to both sides. Hopefully that's what you did. First, hold on. There we go. And we got n. I'm going to leave it as -3. I just moved the negative like Lindsay suggested. -1/3. As long as you end up with the same, hopefully will be the same. And we got +1 here. And then I'm going to multiply both sides by -3, which triggers me to flip. Hopefully you guys remembered to flip. Everyone remembered to flip because of that -3 here. We're multiplying by that negative. Okay, so we also want the opposite of that. Inequality symbol. So we got n is greater than -3 for the answer. All right, did I do it right?
Yeah.
You guys agree? Everyone agree? All right. So we got -3, -2, and -4. Make sure you have your numbers going left to right on the number line in the right order. Otherwise, your arrows are going the wrong way. You're going to face the wrong way, and that's not good. Okay? So, Tommy, open or close, buddy? Open. Sam, what direction is the arrow going to point?
To the right.
To the right. Okay, because we're greater than. Very good. Now, can we include -3? No. So we talked about this where we have a division, don't we? We have n over -3, or the opposite of the n over +3 for the original setup. So anybody have a suggestion what we maybe could plug in for our n or our variable that would be convenient for you? Huh. You know what I mean. Cabernet?
0.
You could plug in 0. Yeah? Anything else? Meg?
I have a question.
Oh, sure.
Are we ever going to do problems where we have to, where it's like multi-step on each side?
You mean variables on both sides?
That, or if it was like negative n over 3 minus 5 is less than negative 4 plus 8. Are we ever going to do things like that?
Oh, like you have to simplify both sides before you can even do anything? Absolutely. Yep, we'll get there. Yep. Very good. Cindy, any other suggestions to plug in besides 0?
We could do 3.
You can do positive 3. You guys agree that anything multiple of 3 would work? Right? If you didn't think of 0, well, I would think of 0 would be the easiest one. But remember that when you have that division, remember we talked about plugging in those numbers that are, if it's facing, obviously it's facing the opposite way that it is, we could use like -6, couldn't we? That's divisible by 3 if that's the case. But as long as 0 is the same way as the arrow, I would use 0 or anything that's multiple of 3 on the right-hand side. So we got the opposite of n over 3. Isn't that our original setup before we move the negative? Right? Isn't that negative n? Right? So I'm going to put 0 in there. And we got -5 less than -4. And then we have 0 and -5 less than -4. So is this true?
Yeah.
Yes, it is. I'm not going to write it again. Bailey?
I know it's not a great step, but even if you did use -3 to plug in, it'd still work. And do -6 is less than -3.
If you put in,
No, that would be
No.
-4,
No, it would be
-4.
negative.
it'd be -4, -4. Could be positive 3. Okay? Yeah, those signs do play with you. All right? So be careful with that. But good question. And you have questions on this. Now, I think the next one is distributive property. Now, I'm thinking I would rather stop here and do distributive property and give another one. Yeah, but I want to do ones like this as well.
Oh,
We've never done those before. So I'd rather group if we could, distributive property tomorrow and then work with some of these. Okay, we never touched on those types of equations, so is everyone cool if we stop here? I'll give you about 8 to 9 problems to try of just basic 2-step, flipping or not flipping, and then we move on tomorrow. Is that cool? And then Friday we'll quiz over these types of inequalities, 1-step and 2-step. Good?
Yep.
All right. So we're gonna pause this.